Good evening, students. Already we have uploaded 3 videos on this note 1, which is determinant, and today I am going to share some important and very important some sums of determinant. Hope you will practice these sums each and every day until each and every step becomes clear to you. So let's start today's class. The first sum of today is determinant XA, YB, ZC, YC, ZA, XB, ZB, XC, YA. This determinant is given and we have to show this determinant equals XYZ, determinant ABC, CAB, CAB, BAC, given that X plus Y plus Z equals 0. So this is our first question. Given that X plus Y plus Z equals to 0 and we have to show this determinant equals this determinant. So let's see how to prove it. So first we write the given determinant. The given determinant is determinant XA, YB, ZC, YC, ZA, XB, and then ZB, XC, YA. Now we expand this determinant. So expanding, we have XA first bracket YZ A square minus X square BC plus YB into XZB square minus Y square AC, then plus ZC into XYC square minus Z square AB. So this we get by expanding the determinant. So this equals, now if we see, now we see the result. In this result there are two types of terms. One gives XYZ, here also XYZ, here also XYZ. So we separate these terms. So we write XYZ common. Then we have A into A square, this is A cube. Now B into B square, this is B cube. And C into C square, this is C cube. So this is one term, one group of terms. Now another group of terms contains ABC. See, XA into X square BC. So we get X into X square X cube and A into BC ABC. So taking minus ABC, and here also minus ABC, here also by multiplying we get minus ABC. So taking minus ABC common, we get X cube plus Y cube plus Z cube. Clear? So we have formed two groups, one by taking XYZ common from this product, another by taking ABC common. We know that if X plus Y plus Z equals to 0, this is given to us. We know that factorization formula, X cube plus Y cube plus Z cube minus 3XYZ, this becomes equals to 3XYZ if X plus Y plus Z equals to 0. We know that formula. What is the formula? Again I am telling, X cube plus Y cube plus Z cube minus 3XYZ. This is equals to 3XYZ if X plus Y plus Z equals to 0. So applying that concept, we get X cube plus Y cube plus Z cube. This reduces to 3XYZ. So we have XYZ, then A cube plus B cube plus C cube minus ABC into this becomes 3XYZ. Which term becomes this term? This terms become 3XYZ. Now we take again XYZ common, then we get A cube plus B cube plus C cube minus 3ABC. So this gives the simplified value of this determinant using the condition x plus y plus z equals 0. Now we have to prove that the second determinant which I have erased is also equals to this value, and that the determinant was XYZ, determinant ABC, CAB, BAC. We have to show this value equals to the previously proved result. So this is equal to XYZ, third bracket. Now we are expanding A into AC minus AB. Then we have ABC, BCA, CAB. I think it should be BCA. It should be BCA, CAB. So this becomes A into BC minus A square plus B into AC minus B square plus C into AB minus C square. So we have XYZ, determinant ABC. This is equals ABC minus A cube minus B cube minus C cube. So we have 3ABC here. So taking minus common, we get XYZ, determinant A cube plus B cube plus C cube minus 3ABC. So we get the result of this determinant equals to minus of, listen very carefully, there is a trick in this sum. The result of this determinant reduces to minus XYZ into A cube plus B cube plus C cube minus 3ABC. So this means if we want to get this result, this will be minus of this determinant. So we can write therefore XYZ into first bracket A cube plus B cube plus C cube minus 3ABC. This is equal to minus of determinant minus XYZ of determinant ABC, BCA, CAB, which I have taken. Now multiplying by minus a determinant changes its two rows and columns will be interchanged. So to get the required result, we have to interchange R1 and R2. Sorry, we have to interchange R2 and R3 because we have started by taking ABC, BCA, CAB. But in the question it was given that ABC, CAB, BAC, that is R3 we have taken, which is originally R2, and R2 is originally R3. So by multiplying this minus sign, we get the required determinant, which we have to prove. So this becomes CAB and this is BAC. So this proves the required result. So that means this value and the previously proved result, these two values are equal. So there was a trick in this sum. I think you have understood what was the trick, and if you have not understood, please replay this video again and again. Let's proceed to the next sum. The next sum of today is find the number of real roots. Those who are writing the question, they can write the question. Find the number of real roots distinct of the determinant given, determinant sin x, cos x, cos x. Diagonally we have sin x and all non-diagonal elements are cos x. This determinant equals 0. So this determinant equals 0. So there is an equation given in terms of determinant. So we have to find the number of real roots of this determinant, distinct real roots, and the interval is given x belongs to closed interval minus pi by 4 to pi by 4. This interval, within this interval we have to find how many distinct real roots does this determinant have. So let's apply. We apply R1 operating R1 plus R2 plus R3. We apply this operation to the determinant. R1 operating R1 plus R2 plus R3. So applying, we have delta equals determinant. We denote every determinant by capital delta, which we use generally in triangle. In case of geometry, delta means triangle. In case of determinant, delta means determinant. So applying, we have R1 plus R2 plus R3, means we are going to add R1 with R2 and R3. So applying, we have 2 cos x plus sin x. See, cos x plus cos x, 2 cos x plus sin x, 2 cos x plus sin x. So applying, we have 2 cos x plus sin x. Let us rub this. Already I think you have written, and those who are seeing the video, I think they have seen what operation we are going to apply. R1 operating R1 plus R2 plus R3. So I am erasing this. Now this is also 2 cos x plus sin x, and this is also 2 cos x plus sin x. Then we have this determinant cos x, sin x, cos x. This is cos x, sin x. Now we can see that 2 cos x plus sin x can be taken common. So after taking common, we get 1, 1, 1, and we get here cos x, sin x, cos x, cos x, cos x, sin x, and this was equal to 0. I forgot to write, this was equal to 0, and this is also equal to 0. Now this implies 2 cos x plus sin x. Now we have 1, 1, 1 format here, so we will try to make it 1, 0, 0. So this is 1, 0, 0. So this is cos x, this is cos x, and this is sin x minus cos x. Sin x minus cos x. This is 0. So what operation we are applying? We are applying C2 operating C2 minus C1, and C3 operating C3 minus either C1 or C2, anyone. So we choose C2. Easily we can choose C1, there is no problem. So C2 operating C2 minus C1. So sin x minus cos x, this is 0. C3 operating C3 minus C2. So 1 minus 1, 0. 1 minus 1, this is 0. Cos x minus cos x. Cos x minus sin x, this is cos x minus sin x. C3 operating C3 minus C2. So this is cos x minus sin x. And this is C3, so sin x minus cos x. Sin x minus cos x. This determinant equals 0. If you are solving with me, then you will have no problem to understand. But even if you are not solving with me, then see the whole video, and next day you must try these sums by yourself. Only then each and every step will be clear to you. So this implies 2 cos x plus sin x. Now 1, 0, 0 format, so we will delete this determinant. So this is deleted. So after deleting, we have determinant sin x minus cos x, and this is cos x minus sin x. We are having this cos x minus sin x. This is 0. This is sin x minus cos x. This determinant equals 0. Now we are having the upper portion. So we have 2 cos x plus sin x into sin x minus cos x whole square. Sin x minus cos x whole square equals to 0. Because expanding, we get sin x minus cos x into sin x minus cos x, that is sin x minus cos x whole square minus 0. So this implies 0. So this implies either 2 cos x plus sin x, this is equal to 0, or from this, if we take this is equal to 0, then sin x minus cos x whole square equal to 0. It means sin x minus cos x equals to 0. So we can write, or sin x minus cos x, this is equal to 0. So from this we have tan x equals to minus 2. Tan x equals minus 2. And from this we have tan x equal to 1. Since x belongs to closed interval minus pi by 4 comma pi by 4. So we have minus pi by 4 less than equal to x less than equal to pi by 4. So we have got both the results in terms of tan. So we have to see the range of tan x in this interval. So we have minus tan pi by 4 less than equals tan x less than equals tan pi by 4. That is minus 1 less than equals tan x less than equals 1. So we can see this is our range of choice of tan x. Now we have got the value of tan x equals to minus 2. So we can put cross to it, because tan x can never be minus 2 in this interval, because the range of tan x is minus 1 to plus 1. So tan x can be either equal to minus 1 or greater than minus 1 and less than equal to 1. So this value is acceptable. So tan x equal to 1. So means x equal to pi by 4. Because tan x equal to 1 gives infinite number of solutions, but we have to get the solution in the range of minus pi by 4 to plus pi by 4 only. In that interval, tan x gives only one value, that is pi by 4. So number of distinct real roots, that was the question. That number of distinct real roots. So number of real roots distinct equals to 1. So this is your answer. If you have not understood any step, please go backward and play the video from where you have not understood. Let's proceed to the next sum. Next sum is, if capital ABC are the angles, those who are writing the question, they write, if capital ABC are the angles of a triangle, then we have to find the value of a determinant. Capital ABC are the angles of a triangle, then we have to find the value of a determinant. I am going to write the determinant on the board. The determinant is minus 1 cos C cos B. Then we have cos C minus 1 cos A. Then we have cos B cos A minus 1. This determinant, we have to find the value of this determinant given that ABC are the angles of a triangle. So if ABC are the angles of a triangle, so we have only one result, that is sum of the angle equal to pi. So we write A plus B plus C equals pi. Now we are going to expand this determinant. So this gives minus 1 into minus 1 into minus 1, this is 1, minus cos A into cos A cos square A. Those who have watched my previous video, that is video part 3, if you have seen the details of the video in YouTube, it is written part 1, note 1. In note 1 there are 3 videos I have uploaded, part 1, part 2, part 3. Separately it is written the video of length more than 35 minutes which I have uploaded yesterday. There this sum is already solved. Those who have not watched the video, for them I am going to solve this sum, because this sum is little bit different, but almost it is the same sum which I have already solved. So 1 minus cos square A, then plus cos C we have cos A cos B plus cos C. Cos C, then we have cos A cos B plus cos C. Then we have cos B, then we have cos A cos C minus plus cos B. So this is the expanded form of the determinant. Now I'm going to simplify. This is 1 minus cos square A is sin square A minus, so minus sin square A. Now from this we get cos square B, so plus cos square B separated and taken together. Now we will get two terms, one here plus cos square C and cos C into cos A cos B, cos A cos B cos C. Here also cos A cos C into cos B, cos A cos B cos C. So we get two cos A cos B, one from this product, another from this product. So we get plus 2 cos A cos B cos C. Now cos square B minus sin square A, there is a formula in trigonometry. So formula is cos of B minus A into cos of B plus A. Clear? Now plus cos square C, no change. Now 2 cos A cos B, I am underlining 2 cos A cos B. 2 cos A cos B we have formula in trigonometry. So formula is cos of A plus B plus cos A minus B whole multiplied by this left cos c. So if you have not understood, please see this portion again by replaying the video, this portion. So this is equal to, now cos b minus a and cos a minus b are same. So this is cos a minus b. Now cos b plus a, we have a plus b plus c equals to pi. So we have a plus b equals to pi minus c. We have a plus b plus c equals to pi. So we have a plus b equals pi minus c. Clear? First of all, pi minus c. And if we apply cos pi minus c goes to second quadrant. Second quadrant cos is negative. So cos pi minus c is minus cos c. So we write directly the value. So this is minus cos c. Now plus cos square c. Now this is again cos a plus b, which will be minus cos c. So minus cos c, third bracket, plus cos a minus b, bracket close, multiplied by cos c. So this is equal to, now this is minus cos c. Okay, so this is minus cos c, cos a minus b. Then we have plus cos square c. I think it is visible. Plus cos square c. Then plus cos c into minus cos c. So it is minus cos square c. And then it is plus cos c into cos a minus b. So these two terms gets cancelled out. Minus cos square c, these two cancel out. So the value of determinant becomes 0. If you have not understood anything, please go back and replay the video from where you have not understood. And if you have not understood any particular step after seeing the video again and again, please comment in the comment box. I will try to explain again this video. Let's proceed to the next sum. So next video we have find the maximum value of theta. Those who are writing, they can write find the maximum value of theta of a determinant. I will write the determinant on the board. We have to find the maximum value of a determinant. The determinant is determinant 1, 1, 1, 1, 1 plus sine theta 1. Then we have 1 plus cos theta and 1, 1. You have to find delta equals to this determinant. You have to find max of delta. This is very, very important question. So many times this question is given in school exam as well as in board exam for 2 marks question. So this is very important and very short length answer type question. This is not at all critical or lengthy question. But if you have not practiced this type of sums, so suddenly if you get this type of sums in exam, so you may be confused. So you must know at least you have to practice 1 or 2 sums where the maximum value of determinant is obtained. Okay, so let's process. So what we do, we operate R2 operating R2 minus R1 and R3 operating R3 minus R1. We can choose R2 also. Why I have chosen this operation suddenly? Because already the format is 1, 1, 1. So we will try to make it 1, 0, 0. Actually, believe me, 1, 1, 1, 1, 1 format is very, in exam, it is very gifted. You will think that it is a gift of God, because directly getting the format of 1, 1, 1 is not expected, because these type of problems may give, but 4 marks problem they will not give 1, 1, 1 format directly. You have to manage it. So this implies this is equal to delta. We will change R1 and R2, so there will be no change in R1. R2 and R3 will be changed. So we will copy. Sorry, I have done a mistake. This will be C1. Whole operation will be on column, because 1, 1, 1 we have in R1. So in R1, so operation will be C2 operating C2 minus C1, C3 operating C3 minus C2 or C1. Same operation but in column. I have done a mistake. Please pardon me. So this is 1, 1, 1 plus cos theta. Now this is 1 minus 1, 0, 1 plus sine theta minus 1 sine theta, and this is minus cos theta. This is minus cos theta. Now we proceed to C3, C3, C3 minus C1. So this is 0, 1 minus 1, this is 0, and this is again minus cos theta. Here the determinant will be closed. So this is equal to, now we get 100 format. So what we get minus sine theta cos theta, minus of sine theta cos theta minus 0, that is minus of sine theta cos theta. So this is your expanded simplified form. Now we have to find the maximum value of this determinant. So this value we can write half as minus half, then we get this as 2 sine theta cos theta. This is equal to minus half sine 2 theta. Now we know the range of sine 2 theta. Range of any sine function is -1 to +1. So -1 less than equals sine 2 theta less than equals to 1. Now we are going to multiply this value by minus half on both sides, in all the terms by minus half. If we multiply by minus half, since we are multiplying by negative number in an inequality, so inequality sign will change. This less than equal to will become greater than equal to, and this less than equal to will also become greater than equal to, since we are multiplying by minus in an inequality. So let's see what happens. By multiplying by minus half, we get half, greater than equals, see the changes, less than equals becomes greater than equals. So greater than equals to minus half sine 2 theta greater than equals minus half. So we get both the greater than equal to sign. So we can rearrange this as, this implies we are not doing any changes here, only we are writing in terms of less than equal sign, rearranging the terms. So minus half less than equals minus half sine 2 theta less than equals half, and this was your delta. So what we see, the value of delta is greater than equal to minus half and less than equal to plus half. Again I am telling, the value of delta is greater than equal to minus half and less than equal to plus half. So what is the conclusion? What is the maximum value? The maximum value is half. So the max value is half. So we can write here, so the max of delta, that is this determinant, equals to half. So the max value of determinant is half. Clear? This is a very important and 2 marks short question, a different type of problem. In last video I have also told that please practice different types of problems. You can practice so many sums, but you must see that you are practicing different types of problems or same types of problems again and again. If you are practicing same types of problems again and again, and suddenly a new type of problem is given to you, so you'll be confused. So that's why change of problems must be there. You choose 5 or 6 sums based on each and every type. Like this type 1 I have shown you. If you get similar type of sum in your book, R. Sagawal, NCRT, R.D. Sharma, whatever the book you are doing, that doesn't matter. But you must practice another sum, at least 1 or 2, based on this pattern. Let's proceed to the next sum. This is an MCQ type question. Next sum is an MCQ type question, and it's a very good question. This is also a very different type question. The main problem I am facing with my board, actually I am using a very small board due to I don't have any space in my room. So, and the lighting effect is also there, light is not proper because I am locked down in my home, so I can't go to my center. So there I have the big board. So once I will go there, I will upload a proper video with proper lighting and board facility. So next question is, so those who are writing, they can write, if fx equals determinant. So we have fx equals determinant 0, x minus a, x minus b, then we have x plus a, 0, x minus c, then we have x plus b, x plus c, 0. This is given fx. See the different type. This is given fx. Now what is the question? Then options are given. Then option number 1, f of a equals 0. Option number 2, fb equals 0. Option number 3, f of 0 equals 0. Option number 4, f of 1 equals 0. These are 4 options given. You have to choose. So first, I think you have written the question. Those are not written, please they go back to the video and see the video again. So I am going to erase this options. I have in my mind the options. The options are f of a equals to 0, f of b equals to 0, f of 0 equals to 0, or f of 1 equals to 0. So let's try with f of a. So if this is fx, so what is f of a? F of a means x will be replaced by a. So this is 0, a minus a 0, a minus b. Now this is a plus a 2a, this is 0, this is a minus c, this is a plus b, this is a plus c, and this is 0. So from this we can see the value of this determinant, it is not in any order. That is, if we take every determinant is a square matrix. This is a correspondence. There is a correspondence between a square matrix and a determinant. So if we convert this determinant into a square matrix, we can say this can neither be symmetric matrix nor can be skew symmetric matrix, because a plus c repeated once, a plus b once, a minus b once, a minus c once. Okay, so if we take the transpose of the matrix, there is no chance of getting the same matrix or the negative of the matrix. So we ignore this case. So why we ignore? Because if we take the corresponding square matrix and take the transpose of that matrix, we can never get the similar matrix for the matrix to be symmetric, or we cannot get the negative of the matrix for which the matrix can be skew symmetric. So we ignore this case. Let us try f of 0. Now we try f of 0. Now if we take f of 0, what type of determinant we will get? So determinant will be obtained 0. This is minus a, this is minus b, and this is a, this is 0, minus c, b, c, 0. Now we can see here a very interesting result. A, b, minus a, minus b, plus c, minus c. So there might be a chance that if we take the corresponding square matrix and the transpose of the matrix, so we may get the similar matrix, that's the 3 by 3 square matrix, or the negative of that matrix, because the elements are repeated. You have to notice that the elements are repeated or not. If in the determinant there is no repetition of any element, or one element repeated, other elements are not repeated. So each and every element must be repeated. See here, 0, 0, a minus a, b minus b, c minus c, again 0. So if we take the matrix, let's see, this give us the symmetric or skew symmetric matrix. But I think surely one of these will be obtained. So here if we take the matrix, now we go to matrix. So this is 0, minus a, minus b, a, 0, minus c. This is b, c, 0. Now we take the transpose of this matrix. So by taking transpose, those who have not done the matrix, for them I am telling, for taking the transpose, the rows and columns are interchanged in the matrix. So this is 0, a, b, this is minus a, 0, c, this is minus b, minus c, 0. Now easily we can see this matrix and this matrix very carefully, this matrix and this matrix. If we take the minus from this matrix, the last matrix, if we take minus common from the last matrix, we get the first matrix. Why? Because minus a 0, this 0, minus of minus a plus a, minus of minus b plus b, minus of minus c plus c, 0 to 0, minus of a, minus c, minus b. So easily we can write this is equal to minus a. So what we get? After taking the transpose, we get minus a. That means the matrix is skew symmetric. So therefore capital A is a skew symmetric matrix. Capital A is a skew symmetric matrix. So when we choose the transpose and the matrix, when we see there is repetition of the elements, each and every element must be repeated by plus sign and minus sign. In one place plus, another place it is minus. So now there is an important result in determinant. So what we get? The given determinant, this determinant, the corresponding matrix is a skew symmetric matrix. So we can say that this determinant is a skew symmetric determinant. What is skew symmetric determinant? The skew symmetric square matrix. The skew symmetric square matrix corresponds to a determinant which is known as skew symmetric determinant. Clear? And there is a property in determinant. We can prove it in upcoming classes. I will prove the theorems. Mainly I am focusing on the problems, because theory part you will get from the book. So we have a result in determinant, that is skew symmetric determinant of odd order. Skew symmetric determinant of odd order is 0. Now what is odd order? This determinant is of 3 by 3. That means the order of this determinant is 3. So 3 is a odd number, and if you get a skew symmetry determinant of odd number, the value of the determinant becomes 0. So applying that concept, we can say delta equals 0. So this determinant becomes 0. So we get the value of this determinant equals 0. So the question was f of a equals to 0, f of b equals to 0, f of 0 equals to 0, f of 1 equals to 0. So by putting x equal to 0, we get ultimately delta equals to 0. So this is your answer, f of 0 equals to 0. Let's proceed to the next question. Again, it's a different type of question, basically based on 2 marks. So let's have the second last question of this video. Question is, if capital A equals to matrix 2 lambda minus 3, then we have 0, 2, 5, 1, 1, 3. This is the determinant, and this is the matrix, sorry, not determinant, this is the matrix. This is the matrix given to you, and given that A inverse exists, it is given that A inverse exists, then find lambda. Question is find lambda. This is a, believe me, this is a very common question in board exam and school exams. The school exam means that board exam is a final exam of class 12. School exam means the half yearly, annual, unit test, whatever be the exams where the determinant chapter is included. That is a very common question. A matrix is given and inverse of the matrix exists. Based on that, find the value of lambda. Now, we have to discuss for 1 minute A inverse. What is A inverse? A inverse is the inverse of the matrix. Now, what is the inverse? Inverse means every matrix has its own, has an inverse. Every matrix has an inverse. Okay. So, if we multiply that matrix, which is the inverse of the original matrix, then multiplying these two matrices, we get the identity matrix. Okay, that is identity matrix. So if we have a matrix A, capital A is a matrix, and it is multiplied by another matrix B. So multiplying, we have the identity matrix. Then we say that capital B is the inverse of capital A. Now there is a formula to find the inverse of a matrix, which we will discuss in upcoming videos. It is in the next portion, next topic of the matrix chapter. Now we are confined to determinant. So what is the formula for finding the inverse of a matrix? To find the inverse of a matrix, the formula is adjoint A. We will discuss later what is adjoint. We are not discussing here now. By det A. Okay. A inverse equals adjoint A by det A. Now we can see this is a fraction, and a fraction exists when the denominator is not equal to 0. So A inverse will exist when this denominator, that is delta A, that is determinant A, is not equal to 0. Clear? I think you have seen. So since we can write, since A inverse exists, so we must have delta A not equals to 0. That is the determinant. A matrix is given, its corresponding determinant cannot be equal to 0. Otherwise A inverse will not exist. Now, so this implies determinant 2 lambda minus 3. Then we have 0, 2, 5, 1, 1, 3. This cannot be equal to 0. So that A inverse exists. Implies 2. This is 6 minus 5 plus lambda into 5 minus 0 minus 3 into 0 minus 2. This is not equal to 0. So this is 1, this is 2, this is plus 5 lambda, and this is plus 6 not equal to 0. So we have from this lambda not equals to minus of 8 by 5. So lambda not equals to 8 by 5. Let us check again, because sometimes mistake is there in the calculation. So 2 into 6 minus 5 plus lambda into, this is 5 minus 0 minus 3 into 0 minus 2. Okay, so this is our calculation, this is correct. So lambda not equals to minus 8 by 5. Let's proceed to the last question of this video. Again, it is a very different type of problem. all the problems I've set based on the difference level, that is not doing same sum again and again, same type of sum. You will try to practice, try to solve different types of sums, so that all the sums given in the book you can solve by seeing these videos. So this is the last sum of today. If x, y, z, question is if x, y, z are all not equal to 0. Given that x, y, z are all not equal to 0, it means x is not equal to 0, y not equal to 0, and z also not equal to 0. Then we have to find the value of, x inverse plus y inverse plus z inverse. X inverse plus y inverse plus z inverse if determinant 1 plus x 1 1 1 1 plus y 1 1 1 1 plus z, this is equal to 0. So this is your question. This determinant is given, you have to find the value of this, and given that x, y, z are all non-zero numbers. Those who are writing, they write the question. After that I will solve it. Okay, so let us rub the board, because I don't have any space to keep the question on the board. So determinant is 1 plus x 1 1 1 1 plus y 1 1 1 1 plus z, and this is given 0. So what we will do, first we take x common from row 1, y common from row 2, and z common from row 3. So we get x, y, z common. Then we have 1 plus 1 by x, 1 by x, 1 by x. This is 1 by y, 1 plus 1 by y, 1 by y. 1 by z, 1 by z, 1 plus 1 by z, and this is equal to 0. So what we have done, we have taken x, y, z common from R1, R2, R3. Now we operate this R1 operating R1 plus R2 plus R3. This is our operation. So x, y, z, determinant 1 plus 1 by x plus 1 by y plus 1 by z. Here also 1 plus 1 by x plus 1 by y plus 1 by z. Here also 1 plus 1 by x plus 1 by y plus 1 by z. Here 1 by y, 1 plus 1 by y, 1 by y, 1 by z, 1 by z, 1 plus 1 by z. This is equal to 0. I forgot to write. Now we can see this term can be taken common from R1. So we have x, y, z. We take common 1 plus 1 by x plus 1 by y plus 1 by z. Determinant 1, 1, 1. 1 by y, 1 plus 1 by y, 1 by y. 1 by z, 1 by z, 1 plus 1 by z. And this is equal to 0. Now we have the upper portion. We just keep the last line so that we can continue and you will understand. Now from this we have this result. This implies, now we have 1 1 1 format here, so we'll make it 1 0 0. So we have x, y, z, determinant 1 plus 1 by x plus 1 by y plus 1 by z, determinant 1 0 0. So what we operate? We operate C2 operating C2 minus C1 and C3 operating C3 minus C1. We can choose C3 minus C2 also. So we get 1 0 0. Now this is 1 by y, 1 by z. Now 1 plus 1 by y minus 1 by y, this is 1. Now 1 by z, 1 by z, 0. This is 0 and this is 1. So what we get? 1 0 0 format. And this is 1, 1 into 1, 1, 1 minus 0, 0. So we get expanded form of this determinant is 1 minus 0, that is 1. So and this is equal to 0. So we have x, y, z into 1 plus 1 by x plus 1 by y plus 1 by z. This is equal to 0 because this determinant is 1. Now listen very carefully. In the beginning of the answer of this video, what we have in the question, x, y, z are all non-zero numbers. Means x not equal to 0, y not equal to 0, z not equals to 0. Since x, y, z are all non-zero numbers, so their product can also be non-zero. Means x not equal to 0, y not equal to 0, z not equals to 0. So clearly product x, y, z is also not equals to 0. And we have this product equals to 0. So surely we have this term equals to 0. So this implies 1 plus 1 by x plus 1 by y plus 1 by z. This is equals to 0. Reason? Since x not equals to 0, y not equals to 0, z not equals to 0, implies product x, y, z also not equal to 0. So this means 1 by x means x inverse, 1 by y, y inverse, and 1 by z, z inverse. The value is minus 1. So this is your answer. So up to this we have done today. In the next video we will continue from the next sum. I think you have watched the video from first to last. Those who are not watched, please watch the video from first to last. Till if you have any confusion in the video, in understanding, please write in the comment box. I will try to solve your problems. Thank you.